Section 7.2, verifying trig identities. Basically, we're going to be doing proofs. We're proving that certain equations are always going to be true. And that's what an identity is. So they start off and they give us some hints. Hints for verifying identities, or hints for doing these proofs that we're going to be doing. Okay? Hint number 1, learn the fundamental identities. Those are the ones from 7.1. You know, a lot of those you already know. Tangent theta equals sine theta over cosine theta. You know a lot of those. Sine squared theta plus cosine squared theta equals 1. That's an important one that maybe you didn't know. But learn those. You're going to use those kind of over and over again. 2, try to rewrite the more complicated side of the equation so that it's identical to the simpler side. Okay? You're going to be looking at an equation. Whichever side looks more complicated, start with that. 3, it's sometimes helpful to express all trig functions in the equation in terms of sine and cosine. Okay, so this is a useful one. Basically, try rewriting everything as sine and cosine. Then see what happens. Some stuff's going to cancel out. Some terms are going to combine. It's going to turn into one of the fundamental identities. That's a nice little trick. Hint number 4. Okay, and this is probably the hardest one. Usually any factoring or algebraic operations should be performed. Okay? Basically we're using algebra. And I think this is where students really struggle, is because they don't recognize the algebra. Okay? So, you know, if I said something like x squared plus 7x plus 12, most of us would recognize that factors, like Algebra 1 class, into x plus 3 times x plus 4. Okay? I think we usually recognize that. But the problem is, I'm going to give you something that looks a little bit more like trig than like algebra, and you're going to forget all about factoring. Okay? If I said sine squared theta plus 7 sine theta plus 12, that's basically the same exact algebra problem. Okay? You should still be able to factor that. It's just that instead of an x, I have sine theta acting as my x. That would factor into sine theta plus 3 and sine theta plus 4. And so you're combining the algebra skills that you should be good at with the new trig skills and the new trig identities and functions that we're looking at. Okay? So also the sum difference of two trig expressions can be added. We're talking about adding fractions. So if I had like 1 over sine theta plus 1 over cosine theta, we're adding fractions, so treat this like you've always treated adding fractions. We would need a common denominator. And so basically you would give this one a cosine theta, and you would give this one a sine theta, so that they would have common denominator. You'd have cosine theta over sine theta, cosine theta, plus sine theta over sine theta, cosine theta. And the usefulness of this is that those two fractions can now be combined. You've got cosine theta plus sine theta over sine theta, cosine theta. So this hint number 4 is just talking about if there's algebra, there's going to be algebra, there's going to be fractions you can add together, so get a common denominator. There's going to be things that you can factor, or even things that you could FOIL. Get ready for that. I think that's maybe the hardest one. Hint number 5. As you select substitution, keep in mind the side you're not changing because it represents your goal. Okay? Basically what we're going to do is we're going to try to take either the left or the right side of an equation, or we're going to try and manipulate that so that it looks like the other side. Okay? We're going to end up with a true statement. And think about how we verify a solution in algebra class. You end up with a true statement like 7 equals 7 or 4 equals 4. And when we ended up with a statement like that, we knew that it was a solution. This time it's going to end up with something like sine theta equals sine theta. We're looking for this true statement so we will know it's an identity. Okay? I don't know that this stuff is helpful, so I'm going to skip that one. And hint number 6. if an expression contains something like 1 plus sine x, multiplying both numerator and denominator by its conjugate, 1 minus sine x, would give you something that's useful. In this case, it would be if I multiplied those two things together, 1 plus sine x times 1 minus sine x, I would end up with this statement, 1 minus sine squared x. Now, on its face, maybe that doesn't look very useful to you, but if you remember the fundamental identity that says sine squared x plus cosine squared x equals 1, if you rearrange it, and by that I mean subtract that over to this side, you would see that 1 minus sine squared x is equal to cosine squared x. Okay? And so that trick, multiplying both the numerator and denominator by that conjugate, okay, is going to allow us to use the Pythagorean identity here and change that 1 minus sine squared x into cosine squared x. That's going to be a lot easier to manipulate. It's going to be a lot easier to use with something like cancel out or I don't know, simplify. So similar results would happen for any of these statements. A lot of the hard questions in this lesson will use that property, and if you see one of those, a lot of times you're going to want to multiply by that